AMD just released AFMF 2, AMD Fluid Motion Frames 2. And I can tell you right away that this is good. It is actually better than lossless scaling in some parts, in some aspects, and it is slightly worse in some others, but I'll show you that later in the video.
I know.
And in case you don't know what AFMF is, it is AMD Fluid Motion Frames, which is basically the frame generation technique that you can use outside of the game itself, meaning that you don't need to use or you don't need the developers to implement FSR frame generation inside the game for you to be able to use it. Meaning that you can just download these technical preview drivers, enable AFMF2 on your game, on your preferred game, and it will kind of double your frame rate. It still has some visual artifacts here and there, we're gonna see those, but in terms of latency, it just got really good. I mean, less than half the latency of the frame generation that we had before. And that's one of the bad points of AFMF, because it adds more latency usually than the in-game frame generation, because once again, it doesn't have access to the motion vectors, meaning that it has more latency and at the same time the visual quality isn't as good. But this time it is actually really good. But before, let's just lay an eye onto the sponsor.
GVG Mall!
Bringing you lots of software deals like Windows 10, Windows 11, Office 2019 or 2021 with a new Windows 11 design, and for all of these you can use my SKG discount code for 30% off, getting a Windows 11 serial key for $22 and a Windows 10 one for only $15. Then use the key on your Windows settings and you'll have an activated system. And before testing the games, let me just show you the release notes for these technical preview drivers that you have to download in order to use AFMF2 in your RX 7000 and 6000 series card. Okay, you have to download these drivers, otherwise you won't have AFMF2, but instead AFMF1. Now, new features highlights: AFMF2 technical preview, a major advancement in frame generation technology for HyperRX, which, well, you don't have to use it with HyperRX obviously, but yeah. Lower latency and higher performance. AFMF2 enhances fast-paced gaming by significantly reducing frame generation latency and performance scaling through new modes. By the way, we do have new modes. We have now the performance mode and so on, and these modes are actually quite fine. By the way, I can show you right here that we have these modes. So if you go to the gaming tab, you go to the graphics, and you can see AMD Fluid Motion Frames 2. As soon as you enable it, you have the search mode, which basically adjusts AMD Fluid Motion Frames algorithm to respond better to high motion scenes and improve smoothness. Auto will automatically select the ideal setting depending on the game's resolution. Standard is recommended for a gaming resolution of less than 1440p, high is recommended for a gaming resolution of 1440p and greater. However, this can be enabled at lower resolutions to improve smoothness. So you have the search mode, once again standard or high, being the standard usually used for integrated GPUs, for example, integrated graphics, and then we have the performance mode that reduces the potential performance overhead of AMD Fluid Motion, basically reduces the processing that it needs to do in order to deliver you the frame generation, but may lower the image quality during high motion. Auto will automatically select the recommended mode depending on what GPU AFMF is active on. Performance is recommended for integrated GPUs or when playing at high FPS. Quality is recommended for discrete GPUs mostly. But there's way more. Fast motion optimization. Enjoy smoother gameplay and higher FPS with improved frame generation consistency during fast motion. And this is a thing that I also improved. Remember that AFMF had a major flaw that when you move the mouse really fast, it would disable itself. Well, AMD kind of improved this, and it now kind of disables itself just in really extreme scenarios. Just moving the camera around, even if you're moving it faster, AFMF won't disable itself, while AFMF1 would disable itself. We also have improved borderless full screen support, which does have expanded display support mode for RDNA 3 graphics series. Basically, we do have AFMF working with borderless full screen support, although it seems it is only for RDNA 3 cards or the RX 7000 series, which I don't really know why, but maybe it's a typo. If you have an RX 6000 series, let me know if it does work with borderless full screen. And we have expanded API support with Enable AFMF2 for any OpenGL Vulkan, DX11 and 12 titles, meaning that you can now officially use AFMF in Vulkan and OpenGL. And you might say, well, but there aren't really that many titles using OpenGL and Vulkan. Yeah, but what about emulators? Because people using emulators usually use OpenGL or Vulkan, and now that AFMF can kind of be used on those games with those APIs, OpenGL and Vulkan, it will be very, very good for people running emulators and some other applications, of course, but especially emulation. It will be really, really nice for them. And the cherry on top of the cake is this one, Radeon Chill Interop support, which is amazing. AFMF 2 now supports Radeon Chill, providing a low latency FPS capping option. And believe me, this is actually very, very good. I tested it, and even though the latency is much, much lower, once again, less than half of AFMF 1 in the same situation, in the same FPS scenarios, we can now use Radeon Chill to lock the FPS to an even lower overall latency. So we not only have lower latency from the frame generation, much lower actually, but we also have way lower latency from the frame capping. Instead of using RTSS, for example, Rivetener Statistics Server, we can now use a Radeon Chill, which is much better in terms of latency and frame pacing. So it's a win-win situation. Now, to give you an example, we're running 1440p Cyberpunk 2077. As soon as we go to the settings, we have 1440p with Intel XeSS Super Sampling 1.0 in quality mode. This is just an example, of course. So XeSS, high settings with ultra screen space reflections quality, high settings with SSR2 Ultra. It is what it is. Everything, as you can see, and 1440p. We're hovering around 144 frames, which seems, well, quite okay for this card at 1440p high settings, only with SSR2 Ultra. Okay, now what you want to do is all you have to do actually is go to your AMD software, go to the gaming tab. If you have the game opened, it will go to the game immediately, in this case Cyberpunk 2077. And you have the options of AMD Fluid Motion Frames. You enable it. If you want to be sure, instead of select auto, you can go for high, and instead of performance quality, and the anti-lag is immediately enabled. What happens here is that as soon as you go with AFMF, in this case, you want to stay below your monitor's refresh rate, or at maximum at your monitor's refresh rate. In my case, I have 160 Hz, which is not optimal, because as soon as I enable AFMF, I go from 132 to 260, and I don't really want or need 260 Hz, especially in a single player game, because I mean, it makes, or in this case FPS, because I will still be at 160 Hz and I'll have screen tearing because I'm outside of my monitor's refresh rate. So what you want to do right now, instead of using Radeon anti-lag, we go here to Radeon Chill, enable, and we go and lock, for example, the FPS at 78. Or in this case, we can go even 79, I believe, 79. Yeah, we have an FPS locked to 79, and you might ask, why 79 and not 80? Well, 79 because you want to be at least 2 FPS below your monitor's refresh rate in order to avoid those fluctuations, because if you are still at 160 FPS, like in this case we are 79 with AFMF doubling to 158, if we were at 80 doubling to 160, the moment we had some fluctuation, the FPS could go to 161 or 162, and in that scenario we would have tearing for a fraction of a second, and it just wouldn't look good. I was running before the game at 144 native, and this actually feels very, very good. In this case we have, let me just see because the camera is in front of it, 8 milliseconds of frame generation input latency, and believe me, it is really, really good. In terms of input latency, for example, if you look at quality, you can see that we do have in the I don't know how should I call it, in the cross in the middle of the screen, the pointer, not the pointer, I mean, I know the name in Portuguese, but I don't know the name in English somehow. In the middle of the screen, you can see that there are some motion artifacts. But in terms of latency, it is much better. In this exact scenario, running Cyberpunk at 79 FPS or even 78 FPS in the past, in my first video of AMD Fluid Motion Frames, we were having around 20 to 22 milliseconds input latency. And now we have Radeon Chill alongside Fluid Motion Frames 2, and we're basically having, with the two together, we're having 8 milliseconds. So in terms of frame generation, latency, it is just insane. It is really, really good, believe me. I mean, in terms of quality, if we look at the streets, for example, we see that it still lacks quality. For example, if you look at the lamppost, you can see that we still have some artifacts when moving. That shouldn't happen, of course, but most likely they'll improve the quality over time. Remember, this is just a technical preview, and AFMF 2 will continue to improve the same way that frame generation from AMD and upscaling from other brands as well keeps improving too. The overall quality is better than AFMF 1, much better, and remember what I told you? Look, I'm moving the mouse faster, the camera, and look at the frames. 158, 157. In this same scenario, AFMF 1 would completely disable itself and just re-enable itself when I stopped moving the camera. In this scenario, yes, it doesn't disable itself. See, I'm being really, really aggressive, and AFMF isn't disabling itself. So it's much better in this scenario, much better input latency, and overall, yeah, much better quality. And with ray tracing enabled, it goes down to 70. That will then double the frames to 140. And even here, we can see more artifacts because our base frames are lower. We had 79 before, now we have 70. But still, the overall quality is, once again, it's not that bad. Let me just tell you, it isn't as good as lossless scaling. Frame generation, definitely not as good. Lossless scaling has much better quality, but it feels much better than playing at 70 FPS. Much better. So this is, even with artifacts, this is ray tracing at 142, even with artifacts. And now we can disable AMD Fluid Motion Frames. We disable Fluid Motion Frames, we go to the game, and yeah, it just, yeah, feels much, much worse. Now, with the same case scenario, let's try enabling lossless scaling. Now, lossless scaling is opened, and what do we have to do? We're using basically 2x mode, and we have the lossless frame generation 2.2 that also got improved. And on the settings, we have the scale hotkey for Ctrl-Alt+S, and that's what we're gonna do basically. We just need to disable the AMD overlay firstly, because it will enable the other overlay that you can see passing right now on the screen. So we disable AMD's overlay once again. And now we're running 75 FPS, 70 something, 75. Remember that we have locked frames. We have Ctrl-Alt+S. And yeah, lossless scaling is enabled. Now pushing 150 something FPS, 130. Yeah, it is not working correctly as it should. Yeah, I really need to get a recording card, a really good recording card. I can show you though that, for example, if you look at the pointer here on the gun, on the cross, if you move it really fast, you have no artifacts, something that you did have with AFMF 2, and it just doesn't happen here. Now let me just show you this, because lossless scaling works fine and I want you to see that live. That's why I'm recording the monitor back there, and also serves AFMF 2 and lossless scaling also serve to actually, well, to actually do frame generation on games that are locked to 60 FPS. Games like Elden Ring, for example, that as soon as you use these technologies, they will feel much better. So, for example, 60 frames, as you can see, 60 frames, well, it just won't go much over it. Scale, 4, 3, okay, let's see, yep. And now we're at 120, and man, it just feels so good. In terms of visual fidelity, yeah, we do have some issues here on the character's hair. We can see some visual artifacts, but I mean, the fluidity is so much better compared to the normal 60 frames that, I mean, it is an entirely different world. And there is in these games, locked games like Elden Ring, emulators and so on, where AFMF 2 and especially lossless scaling work well. And as you can see, in terms of the frame time is just really good, and the smoothness is just there. It seems that it is just up to the recording, and by this time I already bought an Elgato 4K 60 Mac 2 or something like that, so PCIe recording device for this not to happen basically. Now, PalWorld was actually the first game that I tested when I installed these drivers. I actually had early access, like, I've been testing these drivers for like a week. But in case you don't really know, I bought me and my girlfriend, we bought a new house some time ago, and we're still doing some things, some construction work, let's say that, and we've been quite busy, and that's why I didn't have this video earlier, or at least by the time the drivers were released, because AMD did give me early access, and that's why I know the things that I'm talking about, because I tested it before. Now, what I can tell you is that, well, in this case, 1440p runs quite nicely here, but if you're trying to run 1440p ultra-wide or 4K, this game is actually quite heavy since it uses Unreal Engine 5, and we're still hovering 120 FPS, and this is an XTX, of course. No FSR, no upscaling besides, no XeSS, no FSR, no frame generation from AMD, nothing, no frame generation from Nvidia as well, so it is a mess if you're trying to run at higher frames, and that's where the frame generation or the AFMF2 kicks in. You just go here once again, you open the AMD software. As soon as you go to the gaming tab, it will open immediately in PalWorld. You enable fluid motion frame, high search mode, high performance mode or high quality performance mode. We're gonna go and enable Radeon Chill to 79 once again, to stay 2 FPS below our refresh rate in case we have some FPS fluctuations, of course. And as you can see, we're still having only 8 milliseconds of frame generation input lag. And if you watched my previous video of AFMF1, you know that in terms of frame generation latency, in this same scenario, we were having around 22 milliseconds, and now we're having 8 milliseconds, which is less than half the input latency that we did have before, which is insane. Even in terms of the cross that we have in the middle of the screen, it is actually, yeah, we basically have no artifacts. While with Cyberpunk we did have some artifacts somehow. Don't ask me why. Maybe the algorithm just doesn't work as well with, let's say, bluish colors. But in terms of here, the white colors, yes, as you can see, there's basically no artifacts whatsoever. We do have a little bit of dragging here and there, but it's overall very, very nice. And by the way, the stutters that we're having here are basically due to the recording at the same time as well. But overall, yeah, I mean, it just feels much, much better. And we are basically locking the frames to 79 FPS, meaning that we do have less power draw, we have lower temperatures, and we have less CPU usage. So it's overall a win-win situation, and we're still getting 158 FPS. And now, since the input latency is actually pretty low with AFMF2, yeah, I mean, it just works very, very good. In this game, especially, it works very good. In Cyberpunk 2077, we did have some visual artifacts and so on, but in this game specifically, AFMF2 works very, very well in terms of quality. If you want to know about lossless scaling, I tell you the same that I did before. Lossless scaling in terms of quality works better. Even in this game where AFMF2 is really, really good, it works better than AFMF2. It has less artifacts, it is better overall, but that's about it. In terms of latency, AFMF2 is definitely the king here. And remember about what we read before about AFMF2 supporting Vulkan API? Let's see if that's real or that's true in Red Dead Redemption 2. We're having 86 FPS at 1440p, but I repeat, 1440p maximum settings, absolute maximum settings, no FSR, no whatsoever. Once again, absolute maximum settings. What we can do here is basically, yeah, it's basically the same. We just go here, go to the AMD software, go home, go gaming, and as soon as you press gaming once again, Red Dead Redemption 2 tab will appear. You just enable fluid motion frames, search mode standard, in this case high, and performance mode quality. In this case, we disable anti-lag once again, we enable Radeon Chill, and we'll enable it to 79 FPS. Yeah, it did take a toll on our performance, it went down to 76, but at the same time, we have 76 now doubled to 153. And yeah, in terms of frame generation latency, it is more or less the same. Basically, no latency that I can notice. In terms of visual artifacts, yeah, we do have some. It is nothing really, really noticeable that you can just look by well, that you can just be playing like this and you look at it, yeah. You can look in some scenarios because of the stuttering that we have. For example, having a base of 70 FPS only instead of 78, so lower base frames. And if we move the camera, yeah, we can see that we still have some visual artifacts, but it does work in Vulkan, so that's nice. And if people were using AFMF 1 and for most of them it was fine, I believe that AFMF 2 will be even better since the overall quality is better as well. But yeah, I mean, whoa, something is going on and it isn't working as it should, and maybe that's why this is happening, I don't really know. Well, as soon as I press the Windows key and I tried again, it seems that it fixed it. But yeah, in terms of quality now it is much better. We still have some visual artifacts here in the grass overall, but nothing really astonishing. You can, if you play the game like this at a normal distance, yeah, most of the things won't be noticeable and it will still be better than an overall experience of 73, 74 Hertz. So yeah, I would definitely go to AFMF2 here, but once again, lossless scaling works better. Lossless scaling will deliver you a better image quality, a better image fidelity, but not in terms of latency. You will have definitely 100% higher input latency. So basically it's a trade-off. If you have an RX 6000 or 7000 series and you can't absolutely stand any kind of input latency, AFMF2 is a major uplift because you have way lower input latency, but in terms of overall quality it is just much lower than lossless scaling, especially in scenes with lots of grass, lots of reflections like this one. AFMF2 algorithm still has some issues, well, kind of doing the right thing here, while lossless scaling will be much smoother. Let's try, for example, instead of locking the frames to 79, let's lock the frames to, let's say, 65. As soon as we go to lower base frames, it is even worse. We can see lots of dragging, lots of motion artifacts here in the grass, something that I wouldn't play with. So if you're, let's say, going from 80 to 160, or if you're going from 100 to 200, AFMF2 will be fine in terms of quality. But if you're going below the 70 FPS mark at 1440p or above, yeah, things won't look pretty. As with lossless scaling, yeah, the overall smoothness will be much better. This time we have Last Epoch, a game that I've been playing, by the way. I like it. And we're running 200 FPS in this specific part because the game is really heavy in some parts, but really much lighter in others. Specifically, when you start the game, it is much heavier. And as you can see, 250 FPS. We don't need those FPS. Usually I lock the frames to 105 in this game, specifically 105. We enable the AMD Fluid Motion frames. It will enable it with the Radeon anti-lag immediately, and we now go down from 200 and something to 170. It's normal, but then it doubles the frame generation, doubles the frames, of course, with frame generation to 330 something FPS, 340, and there is only 6 milliseconds of input latency because we have a really high base frame rate. We can enable once again Radeon Chill. It disables Radeon anti-lag. We go Radeon Chill to 78. Let's do 78 this time. It locks the base frames to 78 and then it doubles it to 156, something like that. And yeah, it is smooth, but we can see some motion blur around the character, and that's due to frame generation, something that once again happens way less with lossless scaling, but at the same time the input latency is also considerably higher. If you test both, you can see what I'm talking about because they are different in those scenarios. AFMF2, for now it will improve. Remember, this is a technical preview. AFMF2 will improve in terms of quality as well, but for now AFMF2 works much better in terms of input latency, but compared to lossless scaling it isn't as good in terms of overall quality. I will disable Radeon Chill and we'll frame limit through RTSS to see if the quality gets maintained or if locking the frames with RTSS actually delivers better overall quality. And locking the frames with RTSS instead of locking them with Radeon Chill actually helps, since the frame pacing is slightly better in terms of quality and and stability, it is also better than Radeon Chill in this case scenario. And we go back to Radeon Chill, and yeah, it seems that now it also works better with Radeon Chill. Somehow it actually works better now with Radeon Chill. How is this possible actually? I just went to Windows, I came back, and it now works better with Radeon Chill compared to RTSS. That's not understandable, but yeah. Once again, in terms of quality, lossless scaling is the one you want to get. In terms of a mix, if you don't really want to spend any money and you have AFMF2 ready to be used, yeah, in most scenarios it will be more than enough, especially if you're playing not that close to the monitor, or if you have a smaller monitor, it will be completely fine for you. Because, I mean, even here, it just works well. And remember, I'm recording, because the differences when I'm not recording are actually way less than we see here. But still, I mean, yeah, 78 frames, no issues whatsoever. And well guys, that's all for today's video. We tested Cyberpunk 2077 that doesn't really support frame generation from AMD unless you're using mods. Then we tested PalWorld, where AFMF2 actually works very well. One of the best games to use AFMF2. It really works well. Then we tested Red Dead Redemption 2, and it kind of works not as great, both in terms of frame limiting and in terms of overall quality, because we have lots of things that the algorithm doesn't seem to work well with, like the grass, the foliage, all those things, and it seems that anything below 70 FPS in that game will give us lots of artifacts, at least with AFMF2. Once again, lossless scaling works better in that scenario, but once again as well, it also has more input latency. And then we tested last Epoch, which also works pretty well, pretty decent. Not much, not a huge amount of artifacts. We do have a bit of kind of tearish look or a tearish feel here and there, so not entirely 100% smooth, but in terms of the overall experience, yeah, it just works. And the input latency is really, I mean, damn, it's really low. Lossless scaling wins in terms of quality. AFMF2 wins in terms of latency. Thank you very much once again. Now it started raining, and see you in the next video, guys. Cheers.